Hello everybody, this video is going to cover our 5.4 notes. This is going to cover the beginning of trig, and we will be continuing on with right triangles. So we will use trig today and the next set of videos with our right triangles. Today we are specifically going to be talking about the tangent ratio. So in this class so far, we've talked about 3 different ways to find missing sides of right triangles. Those ways were the Pythagorean theorem, that was 5.1. So we've got the Pythagorean theorem. We've got our similar right triangles. That's where we make our table. And then the last set of notes that we did, we talked about special right triangles. And that was my 30, 60, 90, 45, 45, 90. So with Pythagorean theorem and similar right triangles, we don't really need angle information. We just need information about sides in order to be able to find other missing sides. And then yesterday, or the last set of notes that we did, we started talking about how to find missing sides if you know specific angles within your triangle. Well, 30, 60, 90, and 45, 45, 90 are not the only measure of angles that we can have in a right triangle. We can have any measures, essentially. And so the special right triangle ratios only work when we have a 30, 60, 90, and 45, 45, 90. So what happens if we have an angle like 53 or an angle like 61, something that is not our 30, 60, 90, 45, 45, 90, well, we need to find a different ratio that we can use, and that's where trig comes in. So the first ratio that we're going to be using is called tangent, okay? And here it says, on the triangle to the right, label the side that is adjacent and opposite of the given angle, and then I also want you to label the hypotenuse. Based on the information provided to you in your right triangle, you will use one of the 3 different trig ratios. The ratios are as follows. So I have this right triangle here, and then notice that I have this angle down here. And what I want to do is I want to name the 3 sides of my right triangle as either opposite of the given angle, adjacent to the given angle, or I need to label the hypotenuse. Well, we already know what the hypotenuse is. That one's easy. It's the side. Remember that the hypotenuse is the side across from the right angle, okay? Now, we need to label these other 2 missing sides as either opposite of the angle that I have or adjacent. A long time ago, we learned what adjacent means, and adjacent means next to. So the only 2 options that we have for adjacent is this side of our triangle and this side of our triangle. But I already know that that top side is the hypotenuse, so that's not one of my options, okay? So this side down here is my adjacent side. And then the only other side that I have is the side opposite of angle X, and that's going to be this side over here, and we're going to call that opposite. Okay, now the way trig works with sine, cosine, and tangent is depending on where your angle is, and then what side information you were given, you will use one of these 3 trig ratios. So I'm going to show you what the trig ratios are. For tangent, which is what we are doing today, tangent ratios are when you have the opposite side over the adjacent side. So tangent is opposite over adjacent. Sine is when I have opposite over the hypotenuse. So that opposite side will go over the hypotenuse. And then cosine is when we have adjacent over the hypotenuse. So this is going to be TOA, SO, and then ka. So this is how we kind of write these tangent ratios, or these ratios to remember. So tangent is opposite over adjacent, sine is opposite over hypotenuse, and cosine is adjacent over hypotenuse, okay? So these 2 ratios require the hypotenuse, tangent does not. So because we have 2 ratios that will include the hypotenuse, we will do those in our next set of notes, and we're only going to be focusing on tangent today, okay? So today we're focusing on opposite over adjacent, this guy. All right, so here we go. It says solve for x. So notice here that I do have a 45, 45, 90 triangle. So I could essentially use my my special right triangle ratios, but I do want to show you how this works without using my special right triangle ratios. Okay. First thing I need to do is write this thing as a ratio. Okay. This is my given angle right here. I have the side opposite of my angle, and I have the side adjacent to my angle. I don't have my hypotenuse. So my ratio is going to look like this. We're going to have the tangent of 45, and that is going to equal the opposite side, which is x, over the adjacent side, which is 5. Okay? Now, when I do this, okay, the thing that goes in the parenthesis here will always be your given angle. So my given angle was 45. So I'm going to put whatever trig ratio I'm using. In this case, I'm using tangent. So I'm going to put tangent. I'm going to put the angle inside of that parenthesis 45. And I'm going to set it equal to the ratio of the opposite side over the adjacent side. The opposite side was x and the adjacent side was 5. From here, what I would do is I would need to rearrange this equation so that it is solved for x. So I need to have x equals, okay? Although this looks weird, this would be the same thing as saying, like, I'm just making this up, 20 equals x over 5. If I wanted to get x by itself, all I'm doing is multiplying both sides by 5. So down here in this example, I'm going to be doing the same thing. I'm going to multiply both sides by 5 to get 5 out of the denominator. And now I have x is going to equal 5 times the tangent of 45. When we do trig, we always need to do this in our calculator. So what I'm going to do is I'm going to pull up my calculator, and I'm going to show you all of the important things that you need. The great thing is I don't actually need a whole lot in my calculator. Excuse me, scoot over. There we go. Okay. And in order for me to use trig functions, I need to make sure that my calculator is set to degrees. And normally your calculator is just like automatically set to radians. So the way that we change our calculator is we're going to go to mode. And even in your calculator in class, it should be the third option down. So you see normal, scientific, and engineering, that's at the top. You see float and all those numbers there. And then the very next line, that third line says radian and degree. We want our calculator set to degree. So we're going to move our little thing over to degree. And then I'm going to get out by doing second and then mode again. Okay. Now, all I have to do is, as long as x is by itself, I just have to type in what I see. 5 times the tangent of 45, enter. The answer is 5. Now, here's what's really cool. If you think back to our special right triangles, remember that our special right triangles were 1, 1, square root of 2. We had to divide and multiply out. So this would be 5 over 1, which equals 5. My 5 would go inside, and then I would multiply it back out. And whether I do this with my special right triangles or my trig ratios, I'm still going to get 5 as that side. Okay, so that's just showing you how else that we can do it. But that's how you use tangent ratios to find missing sides. Now down here it says use a calculator, find the tangent of 45. So I'm just going to type in tangent of 45, I'm going to hit enter, and I get 1. And the reason that it is 1 is because that is my special right triangle ratio. Example number 2. Here is my given angle. Again, I have the opposite side and the adjacent side. So I'm going to label this O and A as opposite over adjacent. Remember that tangent is opposite over adjacent. So I'm going to write this as the tangent of 60 equals, and then the ratio is opposite over adjacent, so it's x over 5 again. Same thing's going to happen. I'm going to go ahead and multiply both sides by 5 so that x is by itself. And then I'm going to type in 5 times the tangent of 60. And we get this really disgusting decimal. That is 8 point, I'm just going to round that to 8.7, okay? Now, notice that I've given you a 60-degree angle, which means that I could have also done like a 30, 60, 90, okay? Something seems odd to me. What seems odd here? Mode. It's still in degrees. Oh, no, never mind. It's fine. Okay, so I could say that this angle is 30, and I can use my ratios of 1 to square root of 3. Remember, our rule is to divide in, so 5 divided by 1 is 5. Now, if I were to type in 5 times the square root of 3, look at what I get. I get 8.6 repeating, or 8.66, blah, 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 which is what I got the first time when I used my trig ratio. Pretty cool, huh? I think so. Okay, now it says use a calculator to find the tangent of 60 and the tangent of 30. So I'm going to type in the tangent of 60, which is going to give me this. I'm going to show you what that is in just a minute. That is 1.7. And then the tangent of 30, and we're going to get that. Okay, now, square root of 3 is 1.7, which is what we got here. All right, did I do tangent of 30 right? Yeah, okay. All right, so here we go. We're gonna throw ourselves into these trig ratios. Ooh, why are these? Okay, well, I'll fix that, but I don't know why those degree symbols are crazy. All right, it says, this is important, by the way. For 45, 45, 90, and 30, 60, 90, we will continue to use exact values, so we will want to use trig for other right triangles that don't have ratios memorized for us to approximate missing sides and angles. So essentially what I'm saying there is your 45, 45, 90, and 30, 60, 90 right triangles, we're still going to use our special right triangle ratios, our 1, 2 square root of 3 and our 1, 1 square root of 2, okay? All right. Here we go. All right, it says set up your ratios and then find the value of x, round measurements to the nearest tenth. I have to have my calculator for this. So here's my angle. I've got my opposite side, my adjacent side. So I'm going to say the tangent of 56 equals x over 25. We've already learned that we're going to have to multiply both sides by 25 to get it out of the denominator. And x is going to equal 25 times the tangent of 56. So 25 times the tangent of 56, and that's going to get me 37.1. Remember that we want to round to the nearest tenth. Over here, my angle that I was given is 28, so the opposite side is way over here. This is opposite. This side over here is my adjacent side. So we've got to be careful when we set up this trig ratio. So we're going to say the tangent of 28, that's going to equal 10 over x. Now, in all the examples that we've done so far, x was on the top of our ratio, but now x is on the bottom. So we still have to solve this for x, and we're still going to do it the same way that we've been doing. We're just going to have to do an extra step. So I'm going to start by multiplying both sides by x. You can't multiply by the numerator. It doesn't do anything for you. The only way to get rid of the fraction is to multiply by the denominator, even if that means moving your x. So right now I've got x times the tangent of 28 equals 10. But now I got to get x by itself. So what I need to do is I need to divide both sides by the tangent of 28, and I'll show you what this looks like as like a problem. So like this step right here is really like x times 3 equals 10. Like in order to get x by itself, we would divide by 3. We're doing the same thing here. It just looks weird because we have like tangent and then parentheses, but you're still just like right now they're being multiplied together, and the opposite of multiplication is division. Don't make it complicated. Okay. So now we have x equals 10 over the tangent of 28. Okay. And again, I'm just going to put it in my calculator like I see it. 10 divided by the tangent of 28. And that's going to give me 18.8. I'm going to move on. All right, number 3. I have all 3 angles. We don't ever want to look at the 90-degree angle. We only want to look at the other 2 angles that we're given. So you have a choice. You may either choose the 65-degree angle to write your trig ratio with, or you can use your 25-degree angle. It doesn't matter. I'm going to use my 25-degree angle, but I promise you no matter which way you choose to do it, it's not going to matter. I'll show you both ways just for funsies, okay? So this is opposite, this is adjacent. So we can say the tangent of 25 equals x over 48. The other option we have, I'll do this in yellow. This one is now my opposite, and this one is now my adjacent, okay? So my other option would be the tangent of 65 equals, this one is going to be 48 over x. This one will become 48 tangent of 25. And this one will become 48 divided by the tangent of 65. Okay, these are both These both equal x. So I'm going to show you. Ready? We've got 48 times the tangent of 25, and that's going to equal 22.4. And now I'm going to do 48 divided by the tangent of 65. And lo and behold, look at that, we still get 22.4. So it doesn't matter. If you have all of the angles, just pick the one that you like the best. I always am going to like the one best where your x is on top, but it doesn't really matter, okay? This is not an angle. I don't know why I put a degree symbol there. 22.4, no matter which way you chose to do it. Okay, numbers 4, 5, and 6 are going to be done slightly different because in examples 1, 2, and 3, I was given the angle and I'm looking for a missing side. But if we look at 4, 5, and 6, we're actually given two sides and I'm looking for the missing angle. The great thing is I'm still getting to use my tangent ratio because I do have the opposite side and the adjacent side to the angle that I'm looking for, right? So here is the angle that I'm looking at. I'm looking at this angle X, okay? This is still going to be the opposite side, and this is still going to be the adjacent side. So the way that I write this is the tangent of X, because remember that your angle is always the one that goes in the parentheses. That is going to equal 6 over 15. Now, in all the other problems, we had to get X by itself. The problem is right now, X is attached to tangent, and you can't like divide by X. It doesn't work here. But we still have to do the inverse function. Like anytime you're moving things from one side of the equal sign to the other, we're always doing the inverse function. So right now, I have to figure out how to do the inverse function of a trig ratio. And your calculator will do that for you. So what I essentially need to have happen is X needs to come over here and this 6 over 15 needs to come here. And the way that I'm going to do that is I'm going to make this tangent inverse. And I'm going to move that 6 over 15 there, and the X will come there. So if we look at our calculator, if you look at where I've been hitting tangent, that button right above it in blue, you will see a blue tangent with a little exponent of -1. That is the inverse tangent function. And the only way you get to access that is by pushing the blue button first, that second button, and then hitting tangent. So I'm going to hit second first. You see that it's red now, and then I'm going to hit tangent, and it actually just gives me tangent inverse. And then I can just type in 6 divided by 15, close the parentheses, and I get 21.8. So that missing angle is 21.8 degrees. So anytime you're looking for the angle, you need to remember that you are going to be using the inverse function, tangent inverse. Okay, let's do this next example. I'm not going to do all of these for you because I think that you kind of get the gist of it at this point. This is the opposite. This is the adjacent. So I have tangent of X is going to equal my opposite over my adjacent. I need my X and my 12 over 7 to switch places. So I'm going to now make this tangent inverse of 12 over 7 equals X. So second tangent 12 over 7, and that is going to get me 59.7 degrees. Okay. I'm going to skip number 6 because I don't want to do number 6 because it's just another example. Now I'll just do it because it's the only one. For funsies, this is my opposite. This is my adjacent. So we have tangent of X equals opposite over adjacent. Tangent inverse of 8 over 17 equals X. So second tangent 8 over 17, and that's going to equal 25.2 degrees. Okay, don't forget your degree symbol because those are angles that you're missing. Okay, now this one looks similar to what we've been doing. The problem is I have my opposite side, but I don't have my adjacent side. I don't have that. I do have my hypotenuse. So in the next set of notes, we will learn how to do something when we have the opposite and the hypotenuse. This would technically be a sine function because it's opposite and hypotenuse. But at this time, I don't know how to use a sine trig function. I only know how to use tangent. So the great thing for me is this is not what I wanted. This is a right triangle, which means that I can actually just use the Pythagorean theorem to find my missing side. So we've got 8 squared plus question mark squared, and that's going to equal 10 squared. So 10 squared minus 8 squared is 36. So my question mark squared is 36, which means my missing side is 6. So now I have my opposite and my adjacent, and I'm now able to use my tangent. Tangent of X equals 8 over 6 I got to move that over. So I have 8 over 6 equals x. So we've got second tangent of 8 over 6. And that is going to equal 53.1 degrees. Nice and easy. Okay. Let's look at this here. So we have 2 triangles. We actually have 3 triangles. But here's what we have to do. Okay. We have to look at this triangle first. Okay. And then I always have students say, okay, well now we're going to look at this triangle and we're just going to use trig. The problem is I can only use trig when I have a right triangle. And that triangle where 50 is in that corner is not a right triangle. That blue triangle is not a right triangle. So instead, I'm going to have to look at my large triangle. Okay, so I've got the small pink triangle and the big blue triangle. Now, when I look at the big blue triangle, it's going to give me all of this as one of my sides. I'm going to label this whole side Z. And the way that I'm going to be able to solve for x is I'm going to have to figure out what the value of Z is, what the value of Y is, and subtract them from each other. And that will allow me to find the side length of just x, okay? So I'm first going to start with my triangle, my pink triangle that has that 70-degree angle. Okay, so we're going to say the tangent of 70 equals opposite over adjacent. So that's going to be opposite over adjacent. Okay, I'm going to end up with y equals 40 divided by the tangent of 70. So we've got, get out of here, clear. I said clear. There we go. I've got 40 divided by the tangent of 70. That's going to give me this long number, okay? I do need to know what that is. So we're going to say that this is 14.6, but what I'm not going to do is use that up here, okay? I'm not putting that there. I need to make sure that I keep this really big decimal in my calculator because I'm going to have to go grab it again in a minute. The second thing that I'm going to do is I'm going to find the tangent of 50 equals 40 over z. So right now I'm looking for the whole bottom, that x plus y together. I'm looking for that whole thing, okay? We have z is equal to 40 divided by the tangent of 50. Close. 40 divided by the tangent of 50. And that gets me that really big, long decimal, okay? In order for me to find x, I have to do z minus y. So I'm going to scroll up in my calculator and I'm going to grab z minus, and then I'm going to scroll up and I'm going to grab my y that I found earlier. So right now I've got these, the long decimals is what I'm using. Because if I use this rounded value and then I use 33.6 and I round that, I'm getting further and further away from exact form for x. I want x to be as precise as possible. So this is the only way that that's going to allow me to do that. Okay, so I've got that 33.5 minus 14.5. I hit enter and I get 19.0. And yes, you do need to include the 0.0. All right, last one. A road has a 12% grade. What angle does the road make with the horizontal? So anytime that you see this 12% grade, 12% can be rewritten as 12 over 100. Now, a road is not going to be this like aggressively ramped, but essentially you have a road with a ramp, okay? It says, what angle does the road make with the horizontal? So I'm looking for this, okay? When your road has a 12% grade, your top number is going to be your vertical height, and the bottom number is going to be your horizontal distance. It's kind of like slope. It's your rise and your run. So 12 is going to go here for my vertical, and 100 is going to go here for my horizontal. So essentially for every 100 units I'm traveling horizontally, I'm able to travel vertically 12 units. So that I want you to think about like how long 100 is and how small 12 is. Like just for funsies, let's just say inches because we can all kind of see, like visualize what an inch is. So horizontally I have 100 inches. Vertically, I only have 12 inches. That's a really big difference, okay? So that's how roads are like sloped. They're graded like that. So I got to figure out what this angle is. It's going to be pretty small, okay? Now, I'm going to be able to use tangent because I have opposite and adjacent. So tangent of x is going to equal 12 over 100. I'm looking for my angle, so I have to use tangent inverse. And I've got second tangent of 12 over 100, and that is going to give me 6.8. So that angle of elevation is 6.8 degrees. It's very small, okay? And that, my friends, is how we use tangent ratio to find missing sides of triangles that have angles other than 30, 60, 90 and 45, 45, 90. Remember, if you ever see a triangle with a 30, 60, 90 or a 45, 45, 90, we are using our special right triangle ratios. We are not using trig ratios, okay? All right. As always, if you have any questions, go see your teacher during their normally scheduled tutorial times, and I will see you in the next video. Bye-bye.